So basically for the remainder of this unit, we're going to be doing a lot of algebra. Okay. Substitution, solving, more substitution, more solving. Okay, remember we were talking about these systems, and what do we use these systems for? Well, basically we use them to solve certain types of problems. And we've seen types of problems so far that we've verified or that we've solved by graphing. But if you remember, one of the ones we did the other day when we solved it by graphing, we had to approximate the answer, which is not great because a lot of times we want the exact answer. Well, algebra helps us do that. So there's two ways we can solve a system. One is by using substitution, and the other is called elimination, which we'll talk about later on, probably starting Thursday. But I would like to talk about substitution. And the best way to do this really is by an example. So let's say we have these two equations. Okay? (3x plus 4y equals -4, and x plus 2y is equal to 2. Now, the only way we know how to solve these is by graphing. So if we wanted to solve it, we could put each one in y equals mx plus b form, graph them both, see where they intersect, and that's our solution. But if they're fractions, they're going to be hard to read the solution exactly. Okay, here's how we do it using substitution. So I'm going to call each one equation 1, first one equation 1, second one equation 2. Okay. And the next question I'm going to ask you is, if I asked you to take one of the equations and get x or y by itself, which one looks like it would be the easiest? Second one, and get which one by itself? X, because there's only one step, isn't there? So what we're going to do in number 2, we're going to solve for x. So x plus 2y is equal to 2. I'm going to pull this 2y over to the other side by subtracting 2y. And I get x equal to, and you could write it two ways. You could write it -2y plus 2, or you could write it as 2 minus 2y. Both of them will get you the same answer. I'm going to write it like this. I'm going to put the -2y in front of the 2. Now notice I've got one of the equations, one of the variables by itself. What I can do now is I can take this value for x, this expression, and plug it in for x into the other equation. When I do that, I'm going to have an equation that just has y's in it, which means I can solve it. So what I'm going to do now is I am going to substitute this expression, and I use parentheses, -2y plus 2 for x in the other equation. So in equation 1. When I do that, I'm going to get an equation that just has y's in it, so I'm going to solve for y. So instead of writing 3x, I'm going to write 3 and then in parentheses this. So 3 negative 2y plus 2, and then finish writing the rest of the equation. Plus 4y equals negative 4. So you see how we can use substitution to help us solve. And if we get this variable, it's easy to get the other one, because you just take that answer and plug it back into one of the original two to get x. But you got to remember your grade 9 algebra. Okay? I got to get rid of parentheses. I got to collect like terms, and I got to get y by itself. So if I multiply everything inside by 3, what does this look like? Right? Plus 4y is equal to negative 4. Keep going. Can I simplify this side further? Yeah, I can collect the y's to negative 2y plus 6 equals negative 4. And now it's a two-step equation. You guys should be very familiar with how to solve these. Subtract 6 from both sides. So I get 2y is equal to negative 10. And then divide both sides by negative 2. So y gives me, or y is exactly 5. I'm halfway there. I found y. Now I just have to find x. Well, to find x, we sub what we just found for y in one of the original equations. Which one would you like to use? Doesn't matter. Remember, these are going to be solutions to both of them, so it doesn't matter which one we use. 2? Sure. So let's plug it back into 2. And that's going to give us an equation that just has x in it. So we can solve for x and get our answer. So that means it's going to be x plus 2 times 5 is equal to 2. I got that right? Yeah. And then we solve for x. Well, 2 times 5 is 10. Take the 10 over to the other side, and x is negative 8. There's your two answers. So you would write as the final answer x equals negative 8, y equals 5. Or you could write it as a coordinate, because that's the point where they would intersect if you graph them. That's substitution. So what it is, it's a series of substitutions to allow you to solve for one of the variables first, and then use substitution again to allow you to find the other variable. Okay? But you do have to remember your algebra. You're simplifying. You're solving equations. Any questions? Okay, let's have a look at another one. Let's try this one. So first thing I'm going to do is I'm going to label them 1 and 2. You don't have to do this. You don't have to write all the steps. I find it easy. It allows me to keep track of things. So remember, we got to take one of the equations and get one of the variables by itself. And I want to do it in as few steps as possible. So which one do you think? Solve for y in number 2. Because it's only one step. So 4x plus y is equal to 5. I'm going to take the 4x over to the other side by subtracting. and I get y equals 5 minus 4x or negative 4x plus 5. Either one will work. Thanks. So now you got to take that value for y and put it in for y in the other equation. So now what we're going to do is we're going to substitute what we just found for y, which is negative 4x plus 5, for y, in the other equation. So in equation 1. And when we do that, we're going to get an equation that just has x's in it. Which means we can solve for x. So what does it look like when we substitute it in? Well, first equation is 2x minus 4, and then instead of y, I write what I'm substituting in, negative 4x plus 5. And then I finish the original equation, equals 7. All right, we got to remember got to get rid of the parentheses by multiplying everything inside by negative 4. What do I get when I do that? Positive 16x minus 20. I can add like terms to get 18x minus 20 is equal to 7. Now 2 steps. Take the number, take the minus 20 first, and then divide by 18. So I get 18x is equal to 27. And x is equal to 27 divide 18, which doesn't divide cleanly. So remember, when we encounter this, we leave it as a fraction, but we make sure it's reduced. What could I reduce this to? What could I divide the top and bottom by? 9. And I get 3 over 2. She's just thanking me for being a good guy. She just sends a message once in a while saying thanks. So I got x. Now I have a choice. I can take that value for x, put it back into 1 or 2, and figure out what y is. So I can sub what I just found, 3 over 2 for x, in one of the 2 equations. Doesn't matter. Doesn't matter now. Which one would you like? 2? Okay. And that's going to let me solve for y. So when I plug this back into equation 2, I'm going to get equation 2 is 4x plus y equals 5. Well, mine's going to be 4x, but I know x is now 3 over 2. Plus 5 equals, what was it? I already forgot it. 5. 4x plus y equals 5, not 5. And now figure out what y is. Well, multiply these 2 together, change that to a fraction. 4 over 1 times 3 over 2. The easiest way to say it. 6. And then bring the 6 over to the other side by subtraction, which gives you 5 minus 6, negative 1. So notice this one, we got a fraction answer. That might have been hard to see if we tried to graph it. So an algebraic method allows us to be a little bit more precise. So we would say our answer is x equals 3 over 2, y equals -1, or you don't have to write both. Write it as a coordinate, 3/2, comma, -1. It's up to you. Are we sort of getting it? Kind of getting there? Okay, you can see the importance of developing those algebra skills from last year. So let's just use that for this last problem that we're going to look at. Oh, there's another one. We're not going to do that. We're going to do this one. Okay. I think we will have done enough. Okay, so create a linear system. Bobby has been saving dimes and quarters to buy a new toy. She has a total of 28 dimes and quarters, and the total value of the coins is $4.30. What are my two unknowns? Dimes and quarters, quarters and dimes. What would you like to name them? X and Y? P and Q? No? You guys like X and Y? All right. So now I got to make two equations involving X and Y from the rest of the information in the question. X plus Y equals 28. Because we're told the number of coins is 28. So that gives me this. The other one must involve this somehow. This represents the value, right? What's the value of a dime? 10 cents. What's the value of a quarter? 25 cents. Which means that you guys said cents. So how would you say this in cents? 430 cents. So keeping track. So if one dime is 10 cents, two dimes is 20 cents, three dimes is 30 cents, how would you figure out how many X dimes is? Just do what to it? Times it by 10. So X times 10, or 10X, gives us the value of the dimes. How would we find the value of the quarters? 25Y. And when we add those two values together, we get the total value in cents. Okay? So remember, change to cents. You could have left it as decimal, but then you would have had to express these as decimals. And why bother with decimals? It's easier to work with whole numbers or integers. Okay, we're ready to solve. And we're going to solve this by substitution. So, what would you like to do first? You've got choices. Whoa, whoa, slow down. All the time. Yep. So take one of the equations and get X or Y by itself. What looks easy? Number one, and it really doesn't matter which one, does it? Because either if I solve for X, I just have to move the Y over. If I solve for Y, I just got to move the X over. Both are easy steps. So let's just say solve for X in 1. So when I do that, instead of X plus Y equals 28, I'm going to take the Y over by subtracting it, which gives me X equals -Y plus 28. Now what? We got to take this and do where and put it where? Into the second equation for which one? For x, right? So we got to take this and we're going to put it in there. So we're going to substitute negative y plus 28 for x in number 2, and that's going to allow us to solve for y. So when we do that, we're going to get, instead of 10x, we're going to get 10 negative y plus 28 in parentheses plus 25y equals 430. Now we've got an equation that we can figure out what y is. And once we get y, we can figure out x. So, what do you want to do first? Yep. What does it look like when I get rid of the parentheses? $280. Notice the number a little bigger. Oh, that's crazy. Next. Yeah, take these two together, make it 15y. Next. Subtract 280. And 430 minus 280 gives us 150. So now we just divide both sides by 10 or 15. And y is equal to 10. So we've just figured out the number of quarters. Now I just got to get the number of dimes. So I just need to sub 10 for y in one of the original equations and solve for x. Well, which one would be easy to plug it into? The first one. Because when you plug it in there, you're going to get x plus 10 equals, how many were there? 28? Yeah, 28. 28. So x is equal to 18. Because this is the problem-solving situation, okay, you should be answering in the sentence. It doesn't have to be a big essay, an introduction, a body, a climax, a summary. You can just write it in one sentence. If you would like to express yourself, I guess you can do so. Maybe I'll give you higher communication marks. She has 10 quarters and 18 dimes. And that's plenty. Okay. That is substitution. Okay. The next one we're going to talk about is something called elimination, where you can actually add and subtract equations. Okay, and we're going to use that to solve for x and y in these type of systems where we have two unknowns and two equations. Okay. For